Hey everyone, welcome to another BTM screencast. Today we're going over Chapter 4, Test and Measurement Instruments Used in Residential Wiring. Some of the objectives are to demonstrate an understanding of continuity testers and how to properly use them, demonstrate an understanding of the differences between voltage tester and a voltmeter, connect and properly use a voltage tester and a voltmeter, demonstrate an understanding of the differences between an inline ammeter and a clamp-on ammeter, connect and properly use a clamp-on ammeter, demonstrate and understand of ohmmeters, megometers, and ground resistance meters. Demonstrate an understanding of multimeters. Connect and properly use a multimeter to test for voltage, current, resistance, and continuity. Demonstrate the understanding of how to read a kilowatt-hour meter. Demonstrate an understanding of safe practices to follow when using test and measurement instruments. And demonstrate an understanding of the proper care and maintenance of test and measurement instruments. Continuity testers, they're a device used to indicate whether there's a continuous path for a current to flow in an electrical circuit or device. While using this, the circuit must not be energized. You can't have power run to it. Voltage testers are designed to indicate approximate values of voltage for either direct current, DC, or alternating current, AC. Most of what we're going to be doing is AC, or alternating current. Identify the grounded conductor of a circuit, check for blown fuses, distinguish between AC and DC currents, and test whether a voltage is present and provide an approximate value for that voltage. Here's some voltage testers. The solenoid type, also known as a Wiggy, may also have a continuity tester, a digital voltage tester, or a non-contact voltage tester, which we'll be using in the lab. Voltmeters used for the same applications as voltage testers, but are more accurate and give more precise information. Analog meters, such as this one, are an older style, and digital meters, such as this, are seen more frequently. Ammeters are designed to measure the amount of current or amps flowing in a circuit, also used to balance the loads on multi-wire circuits and locate electrical component malfunctions. In this case, an ammeter would be used if you believe a certain component is consuming too much. Clamp-on ammeters are easy to use and the most common type. Inline ammeters do not have high enough amperage ratings to make them practical, and they're more difficult to use. So here's a quick look at an inline ammeter and the clamp-on ammeter, which you will see much more. Ohmmeters are used to measure the resistance of a circuit or a circuit component. They must be used only when the circuit is not energized. A megometer, or megger, is used to measure very high values of resistance. As you can see, a megohm is 1 million ohms. A ground resistance meter is used to determine the amount of resistance to the earth when the resistance to the earth through a grounding electrode is not known. Multimeters, which we will be using in lab, measure more than one electrical value. For example, the basic volt-ohm milliammeter can measure DC and AC voltages, DC and AC current, and resistance. Clamp meters combine a clamp-on ammeter with a multimeter. Typically measures the amount of amps flowing through. Can also measure capacitance, frequency, AC amperage, DC and AC voltages, and resistance. Many also measure capacitance and frequency. Watt-hour meters, you've probably seen these outside of your house. They measure the amount of power consumed over a specific amount of time. Electrical power is measured in watts and kilowatts. 1,000 watts equals 1 kilowatt. Kilowatt-hour meters can use digital readouts or dial readouts. Smart meters are a new type of kilowatt-hour meter. It fits right into the regular meter enclosures. It allows a two-way communication between homeowners and the electric utility company. It can automate meter readings, electric service connection and disconnection, and power outages. Safety and meters. Recalibration is necessary from time to time to bring a meter back to its intended level of accuracy. Residential electricians should always follow safe meter practices when using meters of any kind. Always wear safety glasses when using test and measurement instruments. Wear rubber gloves when testing or measuring live electrical circuits or equipment. Never work on energized circuits unless absolutely necessary and you're trained to do so. If you must take measurements on energized circuits, make sure you have been properly trained to work with the live circuits. Don't work alone, especially when working with live circuits. Keep your clothing, hands, and feet as dry as possible when taking measurements. Make sure the meter you're using has a rating equal to or exceeding the highest value of electrical quantity you are measuring. Meter care and maintenance. Keep the meters clean and dry. Don't store analog meters next to strong magnets because magnets can cause the meters to become inaccurate. Handle all meters with care, they are very fragile. Don't expose meters to large temperature changes. Make sure that you know the type of circuit you are testing, whether it's AC or DC. Never let the value being measured exceed the range of the meter. Multimeters, clamp meters, and ohm meters need to have their batteries changed from time to time. Many meter styles have fuses to protect them from exposure to excessive voltage or current values. Be sure to recalibrate measuring instruments at least once a year. That's it for today, and we'll see you next time.